Hi, I'm Michael Mandanas. I'm 14 and a rising sophomore, and I would like to talk with you today about translational motion. Now, in order to discuss translational motion, we will need to know some variables and a few formulas. First variable is delta t. Now, delta t means the change in time. The second variable is delta x, which means change in distance. A means acceleration. V subscript I means initial velocity. And V subscript F equals final velocity. Now, the three formulas that we need to know are delta x equals VI delta t plus 1/2 AT squared. Second formula is VF equals VI plus A delta t. And the final formula is that VF squared equals VI squared plus 2A delta x. Let's do some practice problems. Alright, so a car starts from 0 meters per second and can accelerate at a maximum rate of 12 meters per second squared. Find the car's speed after 5 seconds if it accelerates at its maximum rate starting from rest. Now, this problem tells us a few things. First, it tells us that 12 meters per second equals the acceleration. It also tells us that 5 seconds equals the time. It also tells us that it starts from rest. Now what that means is the initial velocity equals 0 meters per second. Now, what we are trying to find is right here. We are to find the car's speed. Now what that means is that the unknown in this equation is V subscript F, or final velocity. Now, here's a list of everything we know. We know the initial velocity, acceleration, the change in time, and our task is to find the final velocity. Now, let's start with our formula. The formula, VF equals VI plus A delta t. Now, we know these three things, and those three things are on the right side of the formula. So, let's plug in our known values for the parameters in the formula. VF equals 0 meters per second plus 12 meters per second squared times 5 seconds. Now, you'll notice that seconds squared is on the bottom of this unit, and seconds is here. So when you multiply these two together, it cancels out the square, and you're left with simply meters per second. So simplifying, we get final velocity equals 0 meters per second plus 60 meters per second. So the final velocity equals 60 meters per second. Let's move on to a second practice problem. A car starts from 0 meters per second and can accelerate at a maximum rate of 12 meters per second squared. So this is the same car as we just saw in the last problem. So we are tasked with finding the distance that the car travels after 8 seconds if it accelerates at its maximum rate starting from rest. The equation, the problem tells us that 12 meters per second is the acceleration, once again. That we know also that 8 seconds is the change in time, this time instead of 5 seconds. We also know that it starts from rest again, which means that the initial velocity is 0 meters per second. We are tasked with finding, this time, the distance that the car travels, otherwise known as delta x. Let's move on. So, we know the initial velocity, the change in time, the acceleration, and we are trying to find the change in distance. So let's start with our formula. Formula is delta x equals VI delta t plus 1/2 A delta t squared. Now, plugging in our known values for the parameters in the formula, we get delta x equals 0 meters per second times 8 seconds plus 1/2 times 12 meters per second squared times 8 seconds squared. Now, simplifying, we get delta x equals 0 meters plus 384 meters, or delta x equals 384 meters. I hope this was helpful. Thank you for listening. Michael Mandanas signing off.